Math, it's all about math, the wonderful world of math. Welcome to the wonderful world of math, trigonometry time. Double angle identities, examples. Now there are a couple of kinds of examples of how to use the double angle identities. Ones where I give you an angle and ones where I don't give you an angle, but I tell you the value of a trig function at that angle. So here are all of our double angle identities. We're going to do one example of the first type, and then we're going to spend the rest of the time talking about examples of the second type, because the first type, it turns out, is boring. If a equals 5 pi over 6, find sine of 2a, cosine of 2a, and tangent of 2a. The thing about this, and what makes it boring, is that, yeah, I can find sine of 2a in terms of sine and cosine of a. But since I was given a, I can also just find that 2a is 2 times 5 pi over 6, which of course means 2 over 1 times 5 pi over 6, and you look for common factors and reduce them, right? So there's this factor of 2 and a factor of 2, leaving you with a 3. But we don't like to write it. That's messy and terrible. We want to write this like factoring. 6 factors as 2 times 3. That is going to make it nice and easy to see that this becomes 5/3. 5/3. So sine of 2a, notice that we just said here 2a equals 5/3. Sine of 2a is sine of 5/3. I don't need an identity for that. If I give you an angle a, you don't need an identity to find sine of 2a. Sine of 5 pi over 3 is just going to be, in the fourth quadrant, negative radical 3 over 2. Now let's go ahead and do this using the identity. We also know sine of 2a is equal to 2 sine of a, regular a, times cosine of a. What was a? A was 5 pi over 6. So sine of a becomes sine of 5 pi over 6, and cosine of a becomes cosine of 5 pi over 6, right? Okay, so sine of 5 pi over 6 in the second quadrant, that's positive for sine, and negative for cosine. 2 times 1/2, look at that, that becomes 1, and this just becomes negative radical 3 over 2. It's the same answer. That's what you get for being an identity, right? That should give you the same answer. But I didn't need an identity to do that. This was way faster if you know the angle to start with. These become useful when you don't know the angle itself to start with. But because we asked for it, let's see if we can do the same thing for cosine of 2a. We already know what 2a is. Can you find cosine of 2a without the identities? Yes. Try it. Can you find cosine of 2a with the identities? Probably. I want you to try to do cosine of 2a 2 ways, just like we did for sine. Without the identity, just by plugging in 2a, and with the identity. Pause this, and kick me back on when you're ready to go. 3, 2, 1, here we go! Cosine of 2a means cosine of 5 pi over 3. This is in the fourth quadrant, where cosine is positive. So this is going to be positive 1/2. Now using identities, cosine of 2a, let's go ahead and use the first one, is cosine squared of a minus sine squared of a. Well, cosine squared of a, remember, means cosine a parentheses squared. This is going to make it easier for us to plug stuff in here. I just wrote the same thing twice. So cosine of a, sine of a. Cosine of 5 pi over 6. What is cosine of 5 pi over 6? Huh? In the second quadrant, so cosine is negative root 3 over 2, in fact. And that's what you're going to square. You're going to square that cosine value, negative root 3 over 2. And over here, sine of 5 pi over 6. In the second quadrant, sine is positive, so this is 1/2. All of this is 1/2, and you've got to square that. Negative root 3 times negative root 3 is positive 3 over 4. Top times top over bottom times bottom. And 1/2 times 1/2 is 1/4. Well, 3/4 minus 1/4. 3/4 minus 1/4, you've got 2/4, which simplifies or reduces to 1/2. Notice that these are the same answer. Do the same for tangent, if you can. Yeah? Okay, and 3, 2, 1, tangent time. 5 pi over 3 is still in the fourth quadrant, where tangent is negative. Tangent of 5 pi over 3, well, let's see, tangent is sine over cosine. Sine is root 3 over 2, cosine is 1/2. So this is going to be root 3 over 2 over 1 over 2, which fraction divided by a fraction means the fraction times the reciprocal. The reciprocal of 1/2 is 2 over 1, and the 2 on the top and the 2 on the bottom cancel. It's just root 3. So that's tangent of 5 pi over 3, negative radical 3. Using the identity, the double angle formula for tangent says that this is going to be 2 tangent of A over 1 minus tangent squared of A. In this case, A was 5 pi over 3, so 2 times tangent of, A wasn't pi over 3, A was 5 pi over 6. That's what I get for not looking at it. Over 1 minus tangent squared of 5 pi over 6. Right? Because I told you the angle, we plug in those angles for A. Or we can find 2A and plug that in. Right? Yeah, it's just plugging stuff in. Tangent of 5 pi over 6. Well, that's going to be in the second quadrant where tangent is negative. It's negative radical 3 over 3. And this becomes 1 minus negative radical 3 over 3 squared. In the top, you've got, yuck, a compound fraction. And in the bottom, you also have a compound fraction. Radical 3 times radical 3 is 3. 3 times 3 is 9. So this is going to be 3 over 9. And because it's negative times negative, it's positive. So 1, 2, 3 negatives. This is going to be 1 minus 3 over 9. Yuck. Negative 2 radical 3 over 3 equals, over 9/9 minus 3/9 equals, you ready for this? Negative 2 radical 3 over 3 over 6 over 9. And you're going to ask yourself at some point, couldn't I have reduced this a lot sooner? And the answer is yes. You reduce it at some point. Right now is a good time to reduce it. 6 over 9, 2 over 3. Now, this is equal to the numerator times the reciprocal of the denominator. The 2's cancel, the 3's cancel, and this is negative radical 3. Now, some of you might say, did I really have to use the tangent double angle formula? Since I already found sine and cosine, couldn't I have just said that it's going to be sine over cosine? And the answer is yes, you absolutely could have. But we wanted to practice using this tangent double angle formula. So we did, and there it is. Now let's do a real example, like I might actually give you. If sine of A is equal to negative 3/5, not A equals 3/5. Notice I am not telling you what A is. I'm only telling you the Y value when you plug A into sine. This is the output, not the input. No. I've given you the value of the trig function at A. I have not given you A. That's what we did in the last example. This time I've given you sine of A. Yeah? And we've also been told that A is in quadrant 2. This is going to be important later. So we're supposed to find sine, cosine, and tangent at 2A. Sine of 2A. This is where we use the double angle formulas. I don't know what a is, so I can't just multiply it by 2 and get 2a, like we did last time. This time, we're going to use the double angle formulas because it's all we have. Sine of 2a is 2 sine a cosine a. Now, I know this. I can replace this. It is equal to negative 3/5. I don't yet know this, but I can find it. I know that sine and cosine are related using identities. Which identities relate sine and cosine? Go look it up. Find identities that have sine and cosine in them. Okay, so now that you've found them, which ones have only sine and cosine and not a third function? Okay, and now that you've looked at that, which ones have sine and cosine of the same angle? We should have come up with the two ratio or quotient identities, the two cofunction identities with sine and cosine, and the Pythagorean identity. But these guys have sine and cosine and a third function, which we don't want. And these guys have sine and cosine at complementary angles, not the same angle. This is the one that has sine and cosine of the same angle, so this is the one we're going to use. Use the fundamental identity to find cosine a. We know that sine squared a plus cosine squared a is equal to 1. We know further that sine of a is negative 3/5. So we substitute negative 3/5 for sine of a. Negative 3/5 squared, then, plus cosine squared of a equals 1. Negative 3/5 times itself means negative times negative, positive, top times top, over bottom times bottom. 9/25 plus cosine squared a equals 1. Subtract 9/25 from both sides. This leaves us with cosine squared a equals 1 minus 9/25. Get a common denominator, why don't we? 1 is equivalent to 25 over 25. And when I have two fractions that have the same denominator and I want to subtract them, as long as they have that same denominator, I can do it by subtracting the numerators. Now cosine squared of a is equal to 16 over 25. That means that when I take the square root of both sides to get rid of the square, I get cosine of a by itself now is equal to plus or minus the square root of 16 over 25. Well, the top and the bottom both have nice square roots, so let's leave it there. But how do I choose plus or minus? What quadrant is a in? The cosine of a has a sign depending on the quadrant of a. We said at the top a was in the second quadrant. That's where that's important, right here, so that we know we've got to pick the negative square root. So this is negative 4/5. So coming back to it, sine of 2a is equal to 2 sine a cosine a. I was told at the top that sine a, not a, sine a, the four-letter phrase, sine a is equal to negative 3/5. And cosine of a, notice how this says cosine a, not a, cosine a equals negative 4/5. There's a big difference between input and output. A is an input, negative 4/5 is an output. Don't mistake the two. A lot of people mess up on this problem trying to plug negative 3/5 into sine. That's not where it goes. It replaces the whole expression. Yeah. From here it's just simplifying. We're basically done. 2 times negative 3 times negative 4. That's positive, negative times negative. And you get 6 times 4 over 5 times 5. That's 24 25ths. And it's positive. That's that. Cosine 2a. We already did the hard work. This is cosine squared a minus sine squared a. But the hard part was figuring out cosine when we weren't given it. We already know now that cosine of a is negative 4/5, so cosine squared would be negative 4/5 squared. If sine is negative 3/5, sine squared is negative 3/5 squared. 16 over 25 minus 9 over 25, 7 over 25. So there's sine and cosine. And I don't know if we learned anything about tangent last time, but what we should learn is that most of the time, especially if I didn't start out by giving you a tangent, and I didn't, I started out giving you a sine of A. It's easier just to say sine over cosine. 24 over 25 over 7 over 25. Instead of dividing by 7 over 25, multiply by the reciprocal and 24 over 7. So let's do our next real example. If cosine of A is given, not A, but the value of cosine at A, the output, 3 over 7, and A, the angle, is in the fourth quadrant, find these double angle trig values. So if we want sine of 2A, I'm going to need sine of A and cosine of A, but I don't have both of those. I have cosine of A, and I need to find sine of A. So let's do it. We've got to use the Pythagorean identity one way or the other. We might as well do it now. We know sine squared A plus cosine squared A is equal to 1. We also know that cosine is 3/7. So cosine squared means 3/7 squared. Notice that I am plugging in 3/7 not for A, but for cosine of A. Sometimes it helps doing this step to write cosine squared of A as cosine A parentheses squared before you try to plug in 3/7 for cosine A. It makes it easier to see that the 3/7 is being squared when you write it like this. Anyway, what we've got now is a fraction squared. A fraction times itself, top times top, over bottom times bottom. And now we've got to solve for sine of A. So that means subtracting 9/49 from both sides. Sine squared of A equals 1 minus 9/49. Get a common denominator. Subtract. What do you get? Well, the common denominator is 49. So 49/49 minus 9/49, 40/49. Now there aren't any common factors. But to do the next step, to get sine of A from sine squared, we take the square root of both sides. And as before, this means plus or minus. Every time you take the square root of both sides, you say plus or minus. And then for whatever reason, depending on the problem, you pick plus or minus. Which one is it? This is determined by the quadrant of A. The sine of sine, let's write that, these homophones, sine of sine is determined by the quadrant of A. Sine is positive in quadrants 1 and 2, but A was known to be in quadrant, there it is, 4. So we're going to pick this one. This is negative square root 40, and the square root of 49, 7. Okay, now the square root of 40 isn't super nice. We know that 40 is 4 times 10, and that there aren't any bigger perfect square factors than 4. So this is going to be negative square root of 4 times square root of 10. And that's as good as it gets. This is the sine of A. So now, when I ask for the sine of 2A, I have all the parts. 2 times sine of A times cosine of A is sine of 2A. 2 times sine of A. Sine of A. This four-letter expression is equal to this. Negative 2 radical 10 over 7. Cosine of A was given. That's just 3/7. So to simplify, we multiply all this stuff. And remember that the denominator of any whole number, like 2, is an invisible 1. So top times top times top. Negative 4 radical 10 times 3, and 1 times 7 times 7, that's just 49. we did this one step at a time, but you can see negative 4 times 3 should simplify to negative 12 radical 10 over 49. This is our first real answer. Cosine of 2a. We could actually have done this from the very beginning, because we were given cosine of a. We could have done this using an alternate cosine double angle formula. We could have said that this is 2 cosine squared a minus 1. So let's try it, because we can. 2 times cosine squared minus 1. That's 2 times 9/49, we've squared this before, minus 1, and 2 times this fraction helps to remember that this is 2 over 1. Any whole number is written as a fraction itself over 1. So top times top, 2 times 9 over 1 times 49 minus 1. Notice that you're subtracting 1 from something that is less than 1. So the answer should be a negative number. Okay, now this can't reduce. That's just my answer. Tangent. We still have tangent. Tangent of 2a is still best described as sine over cosine. So we get this, we get a compound fraction, and we simplify it. We take the numerator times the reciprocal of the denominator. And we see that there are common factors of 49. Negative times negative is positive. Negative over negative, again, positive 12. Radical 10 over 31. You could use the tangent double angle identity, just like you could use either of the other two cosine double angle formulas. But this is totally valid and acceptable, and we should be able to do this. Cool. So now the next one is for you to try by yourselves. So here's our third real example, and this one honestly is probably the hardest. If tangent of a equals negative 7 over 24, and a is in quadrant 2, find sine, cosine, and tangent of 2a. Why is this the hardest? Because sine of 2a needs sine of a and cosine of a. I didn't give you either of those. Given sine, it's easy to find cosine. Given cosine, it's easy to find sine using Pythagorean identities, right? But given tangent, it's not as easy to find sine or cosine. That's why this one's a little bit harder. But there is a Pythagorean identity that will help. There are 3 Pythagorean identities. What are the other 2? Think about it. The other 2 Pythagorean identities, tangent squared of an angle plus 1 is equal to secant squared of that same angle. And for cotangent and cosecant, we've got this. 1 plus cotangent squared a equals cosecant squared a. I know tangent of a, so that this could actually help me find secant of a. And you might think that I don't care about secant, except that I do need cosine. And secant is the reciprocal of cosine. So if I find secant, I can find cosine. This could actually be very helpful in this case. So let's do it. Let's see how this works. Tangent squared of a means tangent a parentheses squared. This is helpful sometimes, like we said before, for plugging stuff in, not for a, but for tangent of a, the y value for tangent at a. Tangent at a is the fraction negative 7/24. We don't have to do as much solving with this one as we did with the last one, but we do have to add. So 24. Square the top. This is what you get for talking and writing something different. 24 times 24 is 576. So that's that, which means that 1 isn't going to be 24 over 24. It's going to be 576 over 576. But when you add these things, you should get, if I did this right, 625 over 576. So secant squared becomes secant by taking the square root of both sides. And when you take the square root of both sides, you've always got to say plus or minus. Which one do I choose? Plus or minus? What quadrant is A in? Quadrant 2. Quadrant 2, you say? Well, secant is the reciprocal of cosine. Cosine is negative in this quadrant, so we're going to pick this one. Secant of A is going to be 25 over 24 with a negative in front. There you go. Which means that cosine of A, finally getting down to the good stuff here, is going to be the reciprocal, negative 24 over 25. Now, if you've got tangent and cosine, you should be able to find sine. You can use the other Pythagorean identity, go from tangent to cosecant to sine, or you can say tangent is sine over cosine. Now, that's probably what I'd do. Or you could take this with the first Pythagorean identity. That's 3 ways. I'm going to do the second one. So let's say that again. Tangent of A equals sine over cosine. So if you want to get sine by itself, you can multiply both sides by cosine A. That becomes cosine times tangent equals sine. Cosine, negative 24 over 25. Tangent. Tangent way back up here, tangent is negative 7 over 24. Negative times negative, and 24 over 24 both tell us that sine of A is going to be positive 7 over 25. That wasn't that bad, right? Wait a minute, I'm not boxing that, that's not a real answer. We've got sine and cosine and tangent. Okay, now, given that tangent of A is negative 7 over 24, let's, for the first time ever, use the tangent double angle formula for a real example. 2 tangent A over 1 minus tangent squared A. I could have done this from the very beginning if I wanted to, because I was given tangent A for once. And tangent squared means tangent squared. 2 and 24 have a common factor, so reduce that. Instead of saying 14 over 24 and then reducing, you should reduce before multiplying. You get 7 over 12. On the bottom, 7 times 7, and 24 times 24. Negative 7/12 over 576 minus 49 over 576. Simplifying, 576 minus 49 should be 527. So dividing this by this, rewritten, dividing this by this, becomes negative 7/12 times the reciprocal, right? Except that 576 was 24 times 24. That's 12 times 2 times 12 times 2, right? Well, if we take out one of those factors of 12, that still leaves a 2 and a 12 and another 2. That's 12 times 4. So 576 is also 12 times 48. This is helpful because it helps us reduce these factors of 12 that we had here and here, so that we get 7 times 48 in the numerator, which should be 336. So this is finally one of our answers. Now here, what we found, sine and cosine from tangent, should allow us to find these last two. I want you guys to try these on your own. We don't have a lot of time left, so you got 3, 2, 1 to check your work. And here we go. Sine of 2a and cosine of 2a. Notice these numerators should look pretty familiar. Our word of the day is Thescalosaurus, the wonderful lizard. And this has been a Badger Bear production of The Wonderful World of Math.